A-level chemists, let's start from the absolute basics and the concept of the mole. Now, the mole will hopefully be familiar to most, if not all of you, from your GCSE studies. But as you delve deeper and deeper into your A-level, the mole is going to become your very best friend. It is so useful. So again, let's start from the foundations. Now, when we're talking about the mole, it's a measurement of the amount of substance. So in chemistry, when we say amount, we specifically are talking about moles. And the easiest way for me anyway to picture it, to start to think about the mole, to conceptualize it, is just to think of it as any other unit of measurement, any other quantity. Because if I asked you for a dozen donuts, please and thank you would hopefully know to bring me 12. Okay, but if I asked you for a mole of donuts, you would know to give me 6.022 times 10 to the power of 23, because this is the number of particles in 1 mole. And that is 1 mole of any substance, okay? Again, doesn't have to be overly chemical. A mole of donuts, a mole of apples, a mole of atoms, a mole of molecules, all will contain this number of particles. And this number of particles has been given the name based on, the dude that came up with it, Avogadro's constant. In your exams, okay, so whenever you're expected to use Avogadro's constant, you do not need to know this number off by heart. It will be given to you within the context of the question, or it will be given to you in the data sheet or data booklet itself. Okay, but I mean, you're going to be so familiar with it that it will basically live inside of your brain. This is given often the letter L, and I've never asked why. It's got the letter L. And again, this is the number of particles in 1 mole. Now, if we know the number of particles in 1 mole, we can calculate the number of particles generally using the expression number of particles, which I'm going to use as a capital N, is equal to the number, oh, hello, not multiplied by, overexcited, is equal to the number of moles, lowercase n, multiplied by L, which we've just identified as Avogadro's constant, and the amount of willpower and self-control it takes me not to write avocado every single time. Okay, number of particles is equal to the number of moles multiplied by Avogadro's constant. And it's so important, and I want to highlight right now that when we use the word particles, that is a very general term and could be referring to a whole bunch of different things, very chemical. So when we're talking about particles, we could be talking about atoms, we could be talking about molecules, we could be talking about ions, also all sorts, okay? So it doesn't have to be just one type of particle. Let's start to put this into practice. I'm going to show you how the number of particles and how this relates to the number of moles could possibly catch you out. So for these examples, I'm going to keep the numbers themselves really simple so that we can focus on our focus, which is the core understanding. So for this example, if we've got 1 mole of water molecules, how many water molecules are there? Well, that's as simple as it gets, right? We know that the number of particles, in this case, the molecules are the particles. If we've got 1 mole, then we're going to calculate that as, actually, let me switch pens so that it's really obvious what we're doing here. That's going to be the number of moles, which is 1, multiplied by Avogadro's constant, which just equals Avogadro's constant. Do I even need to write it? I mean, I started, so I'll finish. Okay. Where it might get a little bit trickier is when you're asked for the number of a like a smaller unit within a larger unit. So how in still 1 mole of water molecules, how many hydrogen atoms are there? Okay, again, you'll know that they want like a big number and you should use Avogadro's constant because they'll use the word atom or molecule or ion that shows you need to calculate the number of particles. So here we need to consider what is water. Water, of course, has the formula H2O, which means that for every molecule of water, and therefore every mole of water molecules, there are 2 hydrogen atoms. So however many water molecules there are going to be double the number of hydrogen atoms. So how many hydrogen atoms are there? That times 2, which is 1.204 times 10 to the 24. Okay, because you can have more atoms within the molecule than you have molecules themselves. Okay, should we do another example? I think let's do another example. Okay, one more example. How many oxide ions in 0.2 moles of iron 3 oxide? Again, the first thing that we should spot is, because they've used specifically the word ions, which is a type of particle, we know that we're going to need a ridiculous Avogadro's constant related number. And we know that we're going to calculate the number of particles as the number of moles times that. So we have been given the number of moles of iron 3 oxide, but we've been asked for the oxide ions, which are the O2 minus ions, or essentially just the O's. So within 0.2 moles of this, we are going to have 3 times as many oxide ions because there are 3 oxide ions within that formula unit. So the number of moles of just pure oxide ions is going to be 0.2 multiplied by 3, which gives us 0.6 moles. Unit for moles is just mole, which is very satisfying to say. You should try it. And then if we want to now calculate the number of particles, that's going to be the number of moles, 0.6, multiplied by Avogadro's constant, 6.022 times 10 to the 23. And we get something, oh no, where's my calculator? 3.61 times 10 to the 23. Is that an appropriate number of significant figures? Not really, but I think let's talk about significant figures in another video. I hope that this was, well, whether this was a reminder or a refresher for you, or whether this was brand new, I'm hoping that you're feeling nice and confident with like the initial mole concept. And I'm going to be making so many more videos putting moles into practice. So make sure that you have subscribed, make sure that you like this video, please and thank you. And I will see you in the next one.